Today we are going to add and subtract rational expressions. So we're going to do, mostly the ones that we're going to look at are going to have a common denominator to start with. We have some that are going to have, they won't have a common denominator, but we're going to look at those that are not real difficult to do. So we're going to do the simple ones for them. So a reminder that when we're adding with like terms then, or with a common denominator, we have the same denominator. We can just put all of our stuff over it. So if I have A over C plus B over C, that means I have A plus B that over C. All right, so let's get right into it. The biggest thing is going to be, once you're done adding, is going to be simplifying them correctly to see if we can get them in the right form. All right, so here we have 2x over x to the fourth plus 4x over x to the fourth. So since my denominators are the same, I can go ahead and add the numerators. So a reminder that I can write it then as 2x plus 4x over x to the fourth. So we add these together, we get 6x over x to the fourth. And then it's a matter of that you can simplify. Since I have a x in the numerator and 4 of them in the denominator, I can cross one out and we get 6 over x cubed. Letter B. Same procedure. When we put these together, since we have a common denominator, both of them have m plus 4. And so I can write everything over that denominator first. All right, that makes it easier for you. Then we add the like terms in the numerator. So we get m squared plus 5m plus 4. Now the thing is that we have to look at simplifying, and so we need to factor the numerator to see if we can simplify this fraction still. So the factors of 4 that add up to 5, 1 and 4, so we've got m plus 1 and m plus 4 in the numerator, with our m plus 4 in the denominator. So the m plus 4's cancel, and I'm just left with m plus 1. Right. So the big thing is simplifying them correctly once you're done adding them. All right, so you go ahead and do this one here. No. You have a common denominator. You need to put the numerators together first, and then factor. All right. No, you just got to factor now, Chase. So always first we're looking for what they have in common. The 3k and 12 have anything in common. Okay, so take out the 3, factor out the 3. So put right down over here, put a 3 and then your parenthesis. All right. No, okay, and then you need your other parenthesis to go the other way. All right, because what's left when you divide 3k minus 12 by 3? What's left? All right, but you still have the k too, so it's going to be k minus 4 in the parentheses then. All right, so what about the denominator? So what are the factors of negative 16 to add up to 0? No. All right, you multiply them together, they equal 16. 16 times 16 is not 16, right? What is? But they don't add up to 0. So what are the factors of 16? 1 and 16, what else?
8 and 2.
Okay. What else?
4 times 4.
4 times 4. Okay, so if I do 4 minus 4, you get 0, right? Okay, so then you've got, so you're going to have k plus 4 and k minus 4. You factor it. So put that under here. Put them in parentheses. All right, put your fraction bar back in there. No, fraction bars between them. All right, so they have common factors that you can cancel. All right, so what do you got left then? So you got to factor that. Okay, oh, stop, you're done. This right here factored is that. Okay, now you need to put that underneath it. And then you can simplify it. It's negative 18 plus 6. It's 3k. Don't forget the 3k. All right. Now, this should be 4 and 4, right? Plus 4 and minus 4. All right, so you're going to have to factor that too. All right, so when you add these together, so we get 3k minus 12 over k squared minus 16. So we factor the numerator, they have 3 in common. The denominator is the difference of 2 squares, so that's k plus 4 and k minus 4. All right, so the k minus 4s will cancel. We get 3 over k plus 4. Okay, so you just got to remember to factor them and cancel. Right. Okay, subtracting. Now when you're subtracting them, the biggest thing is to remember to distribute the negative, right? So write this one down. And when we distribute the negative, we have to remember that it's just like having a parenthesis, right? So the fraction bar actually works like a parenthesis, so you have to change all the signs, all right? So I'm actually going to write this a couple different ways. So we have 6y minus 6 minus y plus 4 over our common denominator, right? So we can write it that way to start, so that I remember then to take this negative and distribute it. So remember, two things we can think of it as. One way I just need to change the signs, or I can think of there as if there's a negative 1 here, which means I need to distribute the negative 1, so multiply by negative 1. So either way, right? So we get 6y minus 6 minus y and minus 4. Right. Over y squared plus 4y minus 12. And the main thing is here, after you simplify it, all right, check to see if we can do any canceling. So 6y minus y is 5y minus 10, and y squared plus 4y minus 12. Okay, so just like the ones we were working on with adding, then we need to use the same principles and factor. All right, so 5y and 10, all right, they have a 5 in common, so I take the 5 out, left with y minus 2. And factors negative 12 that add up to 4, going to be y plus 6 and y minus 2. So y minus 2's cancel, and we get 5 over y plus 6. So the biggest thing is, if you write it this way, like I did to start with the parentheses, that's fine. If you can just see it, right, and just go to this step here where it says 6y minus 6 minus y minus 4, which most of you can, all right. So if I can see that minus sign there, I need to distribute it, then I'm going to go ahead and do it. So you just have to make sure, though, that you distribute that negative sign. All right. So let's just do letter A down here. Okay. All right, so if we don't have a common denominator, so we have to determine what is the least common denominator first. Then we can add or subtract them. Now, sometimes you have to look at these. Maybe I can actually simplify before I find my common denominator. In this case, we actually can simplify it before we do anything else. That the first fraction here, both the numerator and denominator have a b, so I can actually cancel out a b in that situation. In the second fraction, they both have 3's, in the numerator and denominator, so I can cancel out the 3's. So my first step here is actually going to be to simplify both of the fractions. So if I take a b out of both the numerator and denominator, I have a 1 in the numerator and 2b squared in the denominator. And if we cancel out the 3's, then we have 1 over b squared. Now I look at what does one denominator have that the other one doesn't have. All right. So in this case, the first fraction, the denominator there has a 2. The other one does not. So that means that I need to multiply this fraction by 2 over 2. Get that common denominator. So we have 1 over 2b squared plus 2 over 2b squared. All right. And now I have the common denominators, so I can add the numerators together. So here we just get 3 over 2b squared. All right, so we're just going to look at the simple ones like that today, as far as the without. Right? So if we're subtracting then. All right. Oh, hey, what did I just do? Same thing happens. I lost my B. Okay, all right, so look to see what one denominator has that the other one doesn't have. Now, in this situation, we can still simplify this first fraction. All right? So sometimes that helps, sometimes it doesn't help. But let's go ahead and do it to start with here. All right, so I can take 2 goes into 8 4 times, and I can take a y out. So in the numerator, I'm left with 1. In the denominator, all right, we're left with 4y. All right, because 2 goes into 8 4 times, and I can cancel a y. All right, can't do anything with my other fraction. Oops. So I look to see with what one has that the other one doesn't have. So in this case, the one on the left has just 4y. The one on the right has 4y to the third power. So I need another y squared, right? Because I need to be able to make this y into y to the third power. And the only way to do that is to multiply. So I'm going to multiply both, oops, not 4y. Multiply both the numerator and the denominator by y squared. Because I want 4y cubed in both of them. I have the 4. I need to get y cubed in the first fraction because I have that in the second fraction for the denominator. So this gives me y squared over 4y cubed minus 9 over 4y cubed. So now we can subtract them. We get y squared minus 9 over 4y cubed. Now we cannot do anything with that. I mean, I could factor the numerator, but it won't do me any good because I don't have a y plus 3 or y minus 3 in the denominator. So That would be our answer. So for these, it's a matter of, okay, look at what one has, the other one doesn't have, as far as denominators are concerned with multiplying. Let's see. All right, so do letter A here. All right, so let's look at some story problems that involve these rational expressions. So Roland needs to take supplies by a canoe to some friends camping 2 miles upriver and return, that's good spelling there, return to his campsite. Roland's average paddling rate is about twice the speed of the river's current. So we are working here with distance equals rate times time. So it says, write and simplify an expression for how long it will take Roland to canoe round trip. Okay. So first of all, so we have, and I've made a table here, and maybe this table will help you, that we've got the direction he's going. He's going to go upriver and downriver. We need to know his distance, how far he's going up and downriver. We need to know how fast he's moving, and we need to know his time. Right? So in this problem, we're going to let x equal the speed of the current. Right? Because that's something that's not going to change. Right? The speed of the current is going to be the same whether you're going upstream or downstream. It's just the question is, how does it affect my speed? How fast I'm actually going. All right. So we're going upriver and downriver both ways. So we're going 2 miles each way. So the distance doesn't change. Right? Now it's your speed that matters here, right? And it says that he can paddle twice the rate of the current, right? So if x is the speed of the current, then his paddling speed is 2x, right? Because he's paddling twice as fast, right? So what's his name? So Roland's paddling speed or rate is equal to 2x. Right? So when I'm going upriver, how does the current help me? What does the current do to me when I'm going up the river? Does it help you go faster or does it slow you down? Are you paddling into the current when you're going upriver, or are you paddling with the current when you're going upriver? You guys ever canoed? Anybody ever canoed? All right, which way do you usually go? You usually go with it, right? Okay, how come you would go with it instead of not against it? Okay, it pushes you forward, makes you go faster. So if I'm going downriver, all right, let's go there for a second. If I'm going downriver, if I can paddle at 2x and the river's going at x, we add those together to get our rate going downriver. And if we're going upriver, since the rate of the current is against me, we subtract those. So the speed of Roland going upriver is only x miles per hour. All right, so he's actually traveling upriver the speed of the current. When he's going downriver, it's helping me. so I'm going 3 times as fast. So since distance equals rate times time, then time is equal to distance divided by the rate. So the speed of Roland going upriver is going to be 2 divided by x, right? The distance I want to go divided by how fast I'm going. And my time going down the river is going to be 2 divided by 3x. Okay. So the speed going upriver is only x because we have to take his paddling speed and subtract the rate of the current. And going upriver or downriver, we add that speed of the current to our speed. Right? Same as if you're flying a plane. The speed of the wind is actually helping you. Right? So sometimes if you get on a plane and fly somewhere, if you got a good wind speed behind you, you actually arrive at your destination a little bit sooner than you would expect. So the total time is the time upriver plus the time downriver. So the total time that he is going to be paddling is going to be 2 over x plus 2 over 3x. So let's see, we need a common denominator here. So we multiply the 2 over x by 3 over 3. So we've got 3 times 2 is 6, plus 2 is 8, over 3x is the actual time then it's going to take him to go upriver and downriver. All right, so what was the question there? It said, write a simplified expression for how long it would take Roland to canoe round trip. All right, so here's how long it's going to take him to canoe the round trip. 8 over 3x. So the question is then, if the speed of the current is 2.5 miles per hour, how long will it take Roland to make the round trip? All right. So since x represents the speed of the current, and if that's 2.5, then we take, so time equals 8 divided by 3 times 2.5. So it's approximately 1.07 hours is how long it's going to take Roland to paddle down the river and then come back up the river. If he's smart, he'll go up the river first and then go down the river, right? All right. Okay. So the big thing here is with these problems, make a table help you, all right? How is the speed helping me, or the current, or whatever the situation is? How is that helping me? All right, but everything is situation of distance equals rate times time, or if it's a work problem, okay? Work is equal to how fast you can work times the time it takes also.